Okay, this second video, this is still lesson 49, looking at independent and dependent probabilities. But I'm jumping to the second video, jumping in number 13 and 14, and then I'll go back and do number 3 and 4. Okay, but here, number 13, it says you roll a single die numbered from 1 to 6. It is likely you will roll a number. Is it likely you will roll a number greater than 4? So this is the first row, the first time, and a number less than 2 the second time, less than 2. So this is independent. After I roll the dice, I'm still going to have a 6-sided dice. So the second roll is not going to be affected by the first roll. So therefore it's going to be independent. Okay, so here I work it out here, number 13. So it's independent. So I got dice 1, 2, 3, 4, 5, 6 sides to the dice. So there's a total of 6. So that's the bottom of the fraction. And it says on the first roll a number that is greater than 4 for the first time. So greater than 4, I can't include a 4, so that'll be a 5 or a 6. So the chances of a 5 or a 6 coming up is going to be 2 out of 6 possibilities. So it's 2 out of 6. And then the second one, I still have a 6-sided dice. So in here it says a number less than 2. So that will only be a 1. So the possibility of rolling a 1 the second time is going to be 1 out of a 6. So therefore, just like before, we multiply to see what are the chances of that occurring. So that'll be 2. 2 times 1 is 2. Then 6 times 6 is 36. So it'll be 2 out of 36. And that can actually be reduced down to 1/18, because 2 divided by 2 is 1, then 36 divided by 2 is 18. So it's not very, if I turn into a decimal, I always like doing that to see the probability. So if I go 1 divided by 18, it comes out to, let me do it on the calculator here. Let's see, 1 divided by 18 equals 0.055555. So I'm going to round this second 5 to a 6. So it's going to be 0.0555 or 0.06. I'm going to round it up to 6. So therefore I have a 0.06 chance of rolling a 5 or 6, and then rolling a 1 on the second one, which is not a very good chance. That's like 1, 2 over. That's only a 6% chance. 6 times out of 100. So that's not a very good bet. That's pretty low probability. Okay? So that would be 13. It's independent. Each roll is independent. But number 14 is an example of a dependent, because the outcome of first is going to affect the outcome of a second. Let's see, number 14. It says you have the following coins in your pocket: 5 quarters, 6 dimes, 2 nickels, and 12 pennies. What's the probability as a decimal you will draw a dime and then a penny? So the chances of pulling the dime out and then pulling the penny out. So once you pull the dime out, it's out. It's not going back in the pocket. So therefore, the number of coins in your pocket are going to be less than when you're reaching in for a penny. So this is a dependent, because the outcome is going to be, or the probability is going to change with that missing coin. Okay? So therefore, let's try first here. The chances for a dime would be 25. There's a total. You got 5 quarters, 6 dimes, 2 nickels, 12 pennies. So there's 25. I add those up. There's 25 coins in your pocket. And you're going to first be looking for a dime. So there's a 6 dimes out of the 25. So there's a 6 in 25 chance that it's going to be a dime. But then you want to know your chances for a penny. But one of the coins that's missing might be a dime, and may not be. So the total is going to change. So this is going to change the total to 24 since you already pulled the coin out. Okay, so that's why it's called dependent, because the second result depends on the first result. Okay, the first result is going to change the total of the second. So therefore, and we're looking for a penny, so it's going to be a 12 out of 24 chance. Okay, because one of the coins is going to be missing. You might draw a penny here, but you don't know. But you still put 12 up here. And again, you can reverse it. I mean, people are going, well, what if I do the penny first and then the dime second? Well, it's still going to be the same, because since you're multiplying, it's going to be 6 times 12 or 12 times 6 is going to be the same, and then 25 times 24 or 24 times 25 is going to be the same. Okay? So here now I need to combine these two probabilities to figure out the actual, see what the probability of that occurring, getting the dime on the first row and the penny on the second. So I go 6 times 12 is 72, and then 25 times 24 would be 600. So I got 72 out of 600 possibilities of pulling the dime on the first and then pulling the penny on the second. Okay, so therefore, I always like doing it as a decimal or a percentage to make it easier to see. So 72 divided by 600, I got 0.12 when I did it the first time. Let's see. Do it here. 72 divided by 600 equals, came out to exactly 0.12, which is, move the decimal point over to, that'll be 12%. Okay, so 12% chance of that occurring. Pulling the dime first and then pulling the penny second. Okay, so that's another example of independent and dependent probabilities.